WMPG thrives with support from listeners and from Maine Solar Solutions. Maine Solar Solutions, helping empower homeowners and businesses with solar electric solutions for 10 years. Information at mainsolarsolutions.com.
You're listening to WMPG 90.9 Gorham, Portland, Southern Maine Community Radio from USM. Live from the Orion Cygnus arm of the Milky Way galaxy, this is Scientifically Speaking, a weekly half-hour program devoted to elegant curiosities, and I am one of your hosts, Sarah Chang, and joining me as always is Bernie Rhyme, DJ Star Watcher. How are you, Bernie?
Yes, hi Sarah, thank you, very good.
Bernie is our professor of the Astronomy Lab here at USM and our local protector of the night skies. Reach out to us at WMPGScientificallySpeaking@gmail.com or on Twitter at WMPGSciSpeak. And you can head over to WMPG.org to find the last 5 weeks of archives of all of your favorite shows, including this one. Welcome to another episode of Scientifically Speaking. Joining us today is Professor Yue Zhang, who is a professor of atmospheric chemistry and who studies the chemical reactions of aerosols, the interactions between aerosols and our climate. And today we'll be focusing on two really hot topics. One is on PFAS, found in our environment, in our soils, and how it impacts our climate, and also microplastics. If you joined us last week, Dr. Zhang spoke about aerosols in our atmosphere and how they interact with and help to form or hinder the formation of clouds. And it was a fascinating episode. So hopefully check out WMPG.org for the archive of last week's show. And for this week's show, we are starting off with our conversation on PFAS. Enjoy. So let's move on to some other substances that are apparently also involved in climate change. And one is, I guess they're more like polymers, which are organic compounds. But the first one is on the PFAS substances. You also do research in this area, correct?
Yes. So
Okay.
we actually recently just won our EPA Environmental Protection Agency of US grant to examine the PFAS. So the full name of the PFAS is called per and polyfluoroalkyl substances. So essentially it's anything organic that made of hydrocarbons that chemists substitute some of the hydrogen with a fluorine atom and then to make the PFAS. And then because they're much more durable and less likely to react with oxidants in the air, so they can last much longer. And then they supposedly initially thought like they were less toxic to humans, but now we found that they're actually quite toxic. And that's why we're trying to reduce them now and understand them.
Wow. Yeah, I know in Maine it's kind of a big deal. There's a lot of farms that are, they've stopped operating because they've found that they have a lot of this contaminating their soil. There's a lot of advocacy work around this, and I believe was it recently that was it the EPA or the FDA had like kind of reduced the amount that was considered kind of not toxic, I guess.
Yeah, so I think EPA just announced it maybe about 1 month ago that it sets a standard for the PFAS in the water. And then the reason is because we found that when it's above that level, then it's really toxic to humans. That's why it needs to be reduced. But unfortunately, many areas, the water concentration of PFAS is already exceeding that level. So it really needs to have, both the industry, the government, and public to work together to reduce the PFAS concentration. So part of us was trying to do is to understand what's the concentration of PFAS in the air, and also what can they transform into in the air. When the UV light is there, when the ozone is there, are they going to become something even more toxic, or are they going to become something less toxic?
And so this is what your group is doing, is trying to understand the concentration in the air. Did you just start this work?
Yeah, so we actually are working with two teams at University of North Carolina at Chapel Hill, because at North Carolina there was also a big PFAS issue. So there is very common scientific community where we have different collaborations. So the UNC team actually and us, so we essentially have a collaborative proposal, and then working on understanding the PFAS in the air. So
Interesting.
we were just awarded, I think, in May, so it was still fresh, but we're already starting to working on it, and it's actually quite cool. And towards we're going to work in the lab first to develop all the methods to understand PFAS in the air, and then after that, we're going to put our instrument into a mobile platform, which is a van, and we're going to drive that van across certain PFAS hotspots and trying to understand how much PFAS is really in the air from the actual field deployment.
Wow. Um, so do you know where all the hotspots are in the US?
I know at certain areas, I probably can't name like each individual ones of the whole US. But one thing we're trying to do is we're going to drive the van from Texas all the way to North Carolina. And then there
Okay.
are a few PFAS emitting hotspots that are coming from local industrial activities or factories. So we're going to drive both upwind, downwind of that factory to see how the people living downwind may get affected by the PFAS.
So my understanding is that PFAS is is commonly used in food packaging. Is that kind of, or are there other specific industries that you're kind of targeting?
So yeah, PFAS can essentially it exists in so many different
It's
areas
and
of
everything,
our
yeah.
life. Yeah, it's essentially everywhere. So you're absolutely right. So the food packaging is actually important for PFAS, but then even a lot of times when we make essentially when we cook food, right? So we have these sticky free pans, and then all these sticky free materials actually can also be made from PFAS. And even
Oh.
firefighters, when they actually try to put out fire, the foam they use to extinguish fire is also made of PFAS.
Mm.
So unfortunately, it's really everywhere, and they come from so many different sources, and that's why there are hundreds to thousands of PFAS in the air and in the water and in the soil that needs us to understand.
Wow. Bernie, you used to live on a farm. Was PFAS a thing when you were on the farm?
No, I didn't know anything about it. This was about 3 years ago. It wasn't a big thing, and there weren't any programs on. Like I just heard one recently on main calling. Yeah, I didn't know. You know what the limits are that are now recommended by EPA on PFAS in the air or water or both?
I think it's actually a super low level, which is I think it's down to nanogram. Yeah,
It was like
per
tiny.
super
Yeah,
super tiny actually.
yeah. So it's
Um,
not like the 400 parts per million that of CO2, right? That's what we're at
it's
now.
yeah, it's much
Much
smaller.
less
It's
than that.
only like a super small fraction of the CO2 in the air.
Oh, okay.
Yeah, I heard actually, because of the new lower limits, that the instruments that are used nowadays to detect PFAS don't have the level of resolution to even detect the levels that the EPA has said is the limit. And so I don't know
There's
what
no
we can
problem.
trust now, Bernie.
There's no problem at all. We can't detect that we're fine. No, it doesn't work that way.
Yeah, so I mean that's so true. So what happens is that in the past, the way actually people understand the PFAS, essentially you have to collect PFAS in the air for over the course of 1 week or 2 weeks to be able
Mm,
to collect enough that the instrument can even see and then detect more accurately. So that's why our proposed work that we are working on now is to develop real-time technique that can measure just
mm,
PFAS in the air in real time. And then that's essentially what we're trying to do. So for I was just like doing some quick research while we were chatting, and then for the EPA, actually the concentration of the PFAS they recommend essentially is 0.004 parts per trillion, actually for PFOS, which is for PFOA, and then 0.02 parts per trillion for PFOS. And then these are super low concentration. Essentially, they're almost about 1 in 100 of per trillion.
wow.
So I would say that a lot of the news report even say that's near zero concentration.
Yeah, no wonder they can't detect them. Not even if it's less than a part per trillion. Yeah.
Yeah, you'd have to collect, enough sample for like a month.
Yeah.
Oh,
Why are
wait,
they so
actually,
dangerous then if they're so low concentration? What makes them so
Well, no,
dangerous?
that's just the limit that we're allowed. That
But
won't
they're much
kill
higher
us.
than that. But they're actually
Yeah.
higher than that?
Yeah.
Yeah.
and then
Huh.
so the reason why actually they can be so dangerous here is actually because first of all, the PFAS it's designed to be very stable, so they can stay in the Earth's environment for a really long time, and that's essentially bad, right? Because if you emit something, they can get destroyed by sunlight or something within like a day or 2 days, then they're not that
Mhm.
bad. But PFAS can exist for like 10 years, 100 years. So it allows them to accumulate in nature and build up in your human body within a very long time. You essentially can't get rid of them. So that's why that's one thing, it can cause long-term health effect. And then the other reason is that they actually can compromise, their studies already show that they can compromise the immune and also the cardiovascular systems in human. And then they can also cause infants to have like decreased birth weights as well. So you have lots of bad health effects.
How long have PFAS particles or substances been around for?
Yeah, so this PFAS, they were initially produced, I guess, in the mid 20th century. So have been there for maybe 50 years or maybe even a little bit longer. So around that scale. And then there are different ways people produce PFAS. Initially, it was one type or different types, and now they make new types. So you could actually detect this old type and new type and see like how the concentration changes in the environment. So the older type probably has a higher concentration because they were produced much earlier and keep being
Mm.
dumping into the environment.
Hmm. Can't they
Hmm.
use something in place of that? Like we had the chlorofluorocarbons that hurt the ozone. In like no time we did a huge thing and we got rid of most of them. Can't we do something in place of PFAS?
So people are working on that, trying to find ways to actually produce certain PFAS species that actually is not so persistent. They can get decomposed much easier in the environment. So in that sense, even if we produce a lot of them, but if they can just get eliminated within a few months or a few years, then that's not as bad. And that's one thing people do. The other way is people also trying to find other potential substitutes that can replace PFAS. But overall, because they have been used a lot and they probably producing this kind of old PFAS materials much cheaper than the newer ones. So it's still a slower process. But I'm glad that the government is actually putting all these different advisory and regulation, try to protect the general public health by reducing all these toxic ones and maybe make less toxic ones.
Yeah, that would be a good point of your research also when you show all those spots from Texas to North Carolina and the factories and what they can do. Yeah, it would cost some money, but they have to do it. Yeah.
Right. I always feel like human health is priceless, right? So in that sense,
Yeah.
we do want to try to do what we can within a reasonable extent to reduce the side effects on human health.
Wow.
Right. Yeah, it's important work.
Is there anywhere in the world that doesn't have PFAS?
South Pole.
I would say it's pretty tough because I remember one of my colleagues who actually was analyzing ocean water. I think they might even find some PFAS in ocean water. And if you found in ocean water, it's probably everywhere.
Yeah.
I think they're still doing analysis, but I would say it also depends on concentration, right? Maybe in really remote areas, that the concentration is lower enough that it's not going to cause a significant health risk. But in more urban areas or near the PFAS emission sources, the concentration will be much, much higher that it's going to cause significant health effects.
And so since we're also kind of talking about atmospheric sciences, does PFAS have any impact on climate change?
Well, that's actually one thing we're working on. I think so. One of my collaborator, so actually just found something about PFAS could potentially impact climate. So what happened is that my colleague, his name is Martin, and he used to be a graduate student at MIT. Now he's a postdoc at Yale University. So when he was at MIT, he was working with me, and we worked with a professor, J.C. Close Chamber. So essentially, it's a large chamber. We inject PFAS to simulate how PFAS inject into the atmosphere. Then we turn on all the UV light to simulate sunlight. We found that even though we inject PFAS as gas, but after you turn on the UV light, then they actually get chemically reacting with oxidants to form aerosols. And once the aerosols are formed, so Martin essentially used an instrument to detect how easy it is for these PFAS aerosols to make ice clouds. We found that they are much more efficient in making ice clouds than many other different type of aerosols. So it's very likely, or it's potentially possible that once PFAS is emitted, they may form PFAS aerosol particles, and the aerosol particles can enhance the certain type of cloud formation, and that will essentially change the energy balance of the Earth and affect climate.
Wow. Man, everything goes back to these clouds.
Yeah, so there might be some PFAS clouds already existing in the air.
Oh, gross. Wow. So we've talked about PFAS, we've talked about aerosols. We went back to aerosols from the PFAS. Um, One other kind of pollutant, if you will, is microplastics. And we actually haven't talked about this at all on our show. But it sounds like you have also done some research in the microplastics kind of world and how they impact our environment as well.
Yes. Um, so microplastics has also been a relatively important topic for the past few years. And then they normally come from the decomposition of regular plastics or through mechanical chemical processes. It just becomes really small. And then once it becomes small, then they can get eaten by humans or inhaled by us. So my research focused a little bit more on the airborne microplastics, which really people haven't done much yet. So most of the microplastic work was done in water and how they get in the ocean water or drinking water or food. So we found that, so we think that the airborne might be actually quite bad for you because if you eat it, right, you still have a chance of excrete it out. But if you inhale into your lung and then it get deposited into your alveoli or your lung, then there's no chance it can actually get out anymore and it may just stay there forever. So that's something we're trying to work on with my team. So my students actually have made really great progress in that. We might be one of the first lab. I mean, we're still working on the publication. So until it's published, it's not sure, but we might be one of the first lab in the world to actually develop this online real-time technique to measure microplastic in the air. So
Oh,
that's what
wow.
we're trying to work on. And then we essentially develop first in the lab, then we put this instrument outside and we sample the outside air, and we did find similar trace signals that we see in the lab for microplastics, and we can quantify how much they are.
So if we're talking about like microplastics in the air, that's still like a solid particle in the air, correct?
Right.
So how is that different from an aerosol if an aerosol is also like a solid particle in the air? Is it the size?
Yeah, so actually anything suspended in the air like microplastics, that's actually part of the aerosol.
Oh,
So we essentially call it microplastic aerosol particles. So it's one type of
okay.
aerosols. Yeah.
I see. I see. Interesting. And so would you say that it kind of does the same thing as aerosols in terms of impacting climate change and kind of cloud formation and warming?
Yes, so people have done some study. Um, I don't think people have done much study on how it can impact clouds, which is something my lab may be working on later. People have did do some research on how microplastic itself can have direct effects, which is to scatter sunlight. So they found that if you account for all the microplastic in the air, and then globally speaking, they do contribute because they're white normally. So they do scatter enough light to cause a statistical difference. You can see that the Earth may receive the energy from the sun. So it actually can reduce some of the energy the Earth may receive from the sun, even though they're not that much yet compared with other type of aerosols because we don't have that many microplastics yet. But it's at least significant enough that you can essentially see it on paper.
Wow. And then we're just producing more and more, so it'll
Yeah.
just get worse. Bernie, what has your experience been with microplastics?
Well, I don't know. I mean, I don't. I just have remember reading some things where the numbers for like a drop of water would vary from like 10 up to thousands. I don't know what the exact numbers are, in just like one drop of water. I really haven't looked into what it would be in the air yet.
Yeah.
But
So
depends where it is
I
out there.
oh, excuse me. I recently read some news reports about one is about it's the first time people detect microplastic in human body itself. Like if you draw blood, you actually see microplastic there, they could detect it. And that's pretty scary, right? Because it runs into our blood, which means it's in our circulation system. Um, Another news report I also recently see, and some of my friends even saw, is that people estimate that every week you eat about the same amount of microplastics, about the same weight as a one credit card you may have. So
Wow.
yeah, that's a lot of microplastic eating, right? But luckily, I think most of them can get out eventually, but some of them may actually stay in your body for a long time.
Mm.
I mean, and we're eating things that probably also eat them. So it's
That's
just
true.
everywhere.
Yeah, unfortunately. But hopefully, as people get more and more aware of the microplastics, we can find ways to reduce our intake and be more mindful about that.
Yeah. Yeah.
Yeah.
So I wanted to move on to kind of how we can combat some of this. So there's been a lot of work in the science world and in industry, I guess, if you will, engineering. And I wanted to get your thoughts, Dr. Zhang, because we have an expert here on some of these new technologies and new techniques at trying to reduce some of the things that we've talked about today and on our last episode. So what do you think about these kind of bacteria that have been found to eat and digest plastic, or maybe enzymes that may be able to break down plastics, or potentially, having that applied to microplastics or, PFAS?
I think that's a really great innovative idea. It sounds also very ecologically friendly, right? Because you're essentially using bacterial or biological forces to remove instead of adding more chemicals, which may cause problems later. I did read a paper, I think, about a group of scientists. They discovered this bacteria that can eat plastics, and then it's it's relatively effective compared with the previous ones they found. So I do think that if it does become a huge issue, or maybe even in those landfill places, they can start deploy this kind of bacteria, as long as we'll make sure they're not going to cause more issues to the environment, to maybe consume some of the plastics and then reduce our landfill waste. So I do think that's one good thing, and it does require probably more than that. I would say it requires the whole multiple approach to essentially combat many of the environmental issues. It's not just one approach. A lot of times I think having public awareness is actually very important, because only when all of us start to realize it's a problem, then we can put pressure maybe, or maybe having some influence on the political leaders, so they're going to take effects and then take actions to combat the climate or environmental pollutions. So that's essentially one part we need to do, is from each of our individual person. And another part I would say is that we do need to invest more in the science part, so that we can develop more of this new technology, such as finding the microorganisms can eat plastic, or maybe we'll find a new treatment, or at least help us understand how bad they are and to predict how the future is going to be like. So the policymakers and every public individual can actually make a good, reasonable decision in the long run, right? So that's another thing we need to do. And then the third part is that I do think that the industry and also the government need to work together to find solutions on this, because a lot of the pollution we have actually come from industrial activities or manufacturers. And then only when they start to actually work on it, then in the end of the supply chain, then when our customers purchase them, we can actually feel like much safer that the product we use is going to be less harmful to the environment, or maybe pollute less. So I'll say it's a multiple approaches, and then we have to all combine them together to help combat a lot of the environmental issues we reach nowadays.
Yeah, no, I think that's a very fair statement. We got to try everything we can. Speaking of, government and interventions, the Supreme Court recently limited the EPA's ability in curbing emissions in the U.S. How do you feel about that?
I mean, personally, me and many of my colleagues who are in the field, so we certainly feel very disappointed and sad about this decision, unfortunately. And then the main reason is because that based on the Paris Accord, that the US is also part of it. So we try to reduce the temperature rising of the whole globe and then try to control it within 1.5 degrees Celsius. Even though it's only 1.5 degrees, it actually can make a huge difference because different places will warm and cool differently. And this is average, right? Each year it can be warming up much higher than that. So 1.5 is a very important benchmark in climate sciences that we're trying to work on. And then reducing or limiting the ability for EPA to actually control carbon emissions will certainly be very, I wouldn't say like 100% impossible, but it's going to significantly prevent the US from reaching that goal. And then so likely US may not be able to reach that goal anymore. And then as we know that, US as a country, us as a country actually emits so much carbon into the Earth's atmosphere, and it's a very important component in the whole Paris Accord. So if we cannot do our job well, then even if all other countries do their job, I think the whole climate is still going to potentially reach that 1.5 degree rising benchmark. So which is going to cause lots of other effects that we don't want to see for our future generations. Yeah. So standing from that aspect for the caring of our future generations and also for the environment in general, because not just us, many other species, including both animals and plants, will also get impacted. So we do, I personally do feel very disappointed about that ruling, actually.
Do you have anything to be hopeful for?
Well, I hope that maybe in the future, with the general public getting more, have been more vocal about this, maybe this kind of ruling maybe change, in the future. And also, I also hope that every one of us, should realize that this is really important, not just for us, but also for our future generations. And if anyone, care about any babies of future generations, then we want to actually act now. But in general, I still always believe in humanity. So I do think that even though nowadays, there can be different voices coming up, but I think eventually people are going to realize and reach a consensus that this is a really important issue, and we have to actually make some changes to it so that we can create at least a comfortable life for our future generation and also for the whole Earth. So I still remain hopeful that I think we can actually do this as a race in the whole Earth's history.
Yeah, we gotta all kind of band together, and like you had mentioned, multi-pronged approaches to making a difference.
Yeah, and yes, we can.
I love the optimism there. Well, thank you, Dr. Zhang, for joining us today here on Scientifically Speaking. Really appreciate your time.
Well, thank you very much for having me. It's a pleasure to talk about this.
Absolutely. You have been listening to Scientifically Speaking here on WMPG with myself, Bernie, and Dr. Zhang. Please stay tuned for Something for the Weekend with Anela and from your favorite nerds. Just a reminder to continue to vaccinate and to continue to mitigate, and we will all continue to congregate.